Hey, what's up, guys? Welcome back. Before we get started, I just want to say two quick things. One, to the students who I met this week and the students who I saw through live streaming this week, I just want to say it was great to see you and it was great to be back. That's for sure. And number two, if you're watching this video, please go down to the description below. Download the calculator, the TI-84 Plus. It's free. You can download it right to your computer, or you can download the app on your cell phone through Calculator 84, because you're going to need your calculator for this. And also download the worksheet that I have in the description below, as well as another practice worksheet, so you can then practice this after the lesson. All right? So with that all being said, guys, let's dive right into it. This is a simple one. This is review. We're going to get into factoring the difference of perfect squares soon. So I just wanted to kind of review simplifying perfect squares and kind of go over that quick. All right, now perfect squares we've seen before and we know, right? So what you have here is a radicand in front of the 4. So this is basically saying, 4 is a perfect square, so they want to know what is the square root of 4. And we know what that is, right? The square root of 4 is 2. Okay, so you write that. And why is the square root of 4 2? Well, the square root of 4 is 2 because 2 times 2 gives you 4. And if you're not sure, we could always use our calculator. Same thing with 49, right? You have the square root, the radicand in front of the 49. This is a perfect square because the square root of 49 is 7. And again, why is that? Because 7 times 7 gives you 49. And again, another typical one most students know is if I say, hey, what's the square root of 100? A lot of students will say 10, all right? Notice you have, again, the radicand symbol in front of the 100. So we say 100 is a perfect square. What is the square root of 100? 10, because 10 times 10 gives you 100. Now, let's say you come across a perfect square and you do not know what it is. No problem, we can use our calculator. To find the square root of a perfect square, and you use your calculator, guys, the buttons you're going to want to use are second function, which is this, and then you're going to want to hit x squared. And you'll notice the radicand comes up in the calculator, and we'll look at that in a little bit. Right now, what I want to do is just continue going over very simple perfect squares that are very common and always on the Regents. So, square root of 1 is 1, and I have it done for you because 1 times 1 gives you 1. That's why that's a perfect square. Same thing with 4, which we did up at the top. The square root of 4 we said was 2. Once again, why is that? Because 2 times 2 gives you 4. The rest of these guys go in order, and we're going to fill them in. But what I want you to do, after we fill them all in, I really want you to take a picture of it with your cell phone or write it out. I want you to study this so you have them memorized. Now, if you don't memorize them and you can't memorize them, that's okay. You could always use your calculator. But these are the most common, and it's definitely a good idea to have them memorized. So, the square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. And once again, why is that? Because 5 times 5 gives you 25. And just once again, I have these all going in order so it can help you memorize them. Square root of 36 is 6. Square root of 49 we said before was 7. Square root of 64 is 8. Once again, why is that? Because 8 times 8 gives you 64. Square root of 81 is 9. Square root of 100 we said before was 10. Square root of 121 was 11. Square root of 144 was 12. Square root of 169 is 13, always. Perfect squares never change, guys. 13 times 13 is always 169. Square root of 196 is 14. And last for this, but not least, is square root of 225 is 15. And why is that? Because 15 times 15 gives you 225 always. So we say 225 is a perfect square. Now, what happens if you come across a perfect square and you don't know it? You don't know it in your head, you don't have it memorized, the number's big, whatever. No problem, guys. You go right to your calculator. So, here says the square root of 400, right? 400 is a perfect square. Well, go to your calculator. If you're not sure what it is, you hit second function, you hit the x squared button. Oh wait, whoops, let me clear that out real quick. Second function, you hit the x squared button. Notice, as we said before, the radicand gets pulled up and it's waiting for you to put the number in. You put in 400. Boom, you get 20. So the square root of 400 is 20. And I know I had that in my calculator already. I don't know why I did it twice. Sloppy 20, I apologize. Square root of 625, no problem. Go to, and by the way, these are not in numerical order. So you go second function, x squared. Again, your radicand comes up, you're ready. 625, you hit enter. So the square root of 625 is 25. Square root of 2,500. I do not know what that is in my head. Hit second function, hit x squared. 2500, you hit enter, boom, square root of 2,500 is 50. And finally, last but not least for this, the square root of 10,000. Again, it's a big number. You go to your calculator. Second function, x squared, 10000. You do not put commas in the calculator, guys, when you're dealing with numbers in the thousands. Just keep that in mind. You hit enter, boom, square root of 10,000 is 100. And there you go. So guys, that is the list of the most common perfect squares. And then if you don't know them, that's how you use your calculator in order to find perfect squares. All right. Now what we're going to do is let's look at some perfect squares that have variables and exponents. Okay, guys, notice here with this, we have perfect squares, okay, with variables and exponents or monomials or whatever. Now the only difference with this is, notice it says here at the top, when simplifying perfect squares with variables and exponents, you cannot use your calculator. So what we're going to do here to make this easier, I'll explain how this all works, but really what you're basically doing is, what you do with the exponent, guys, you make life simple and you just divide it by 2. Basically, you're going to cut the exponent in half. Whenever you're finding the perfect square, whenever you're finding the square root of, say, x squared, a to the 4th, y to the 6th, all you do is you keep your variable and you cut the exponent in half. And I'll show you why that is, right? This is very simple. So basically, we want to find the square root of x squared. No problem. Well, the variable we have is x. The square root of x squared is always going to be x. Now, why is it just x? Well, like before we saw what we multiplied here, what you would multiply to get x squared is x times x. X to the first times x to the first is always x squared. Okay? And how do you get x squared? Because, guys, when you multiply monomials, you always add exponents. So 1 plus 1 is 2. So that's how we get x squared when you multiply that. So basically, that's why the square root of x squared is x. Same thing here with a squared. The square root of a squared is just a. Once again, why is that? Because a times a is a squared. Square root of y squared is y. Therefore, the square root of b squared is always b, and the square root of m squared is always just m. And actually, I'm going to change the thickness here on that. Cool. Okay, so the same thing here, but now notice it's not x squared, it's x to the 4th. So what's the square root of x to the 4th? Well, what variable do you have? You have x. So keep x. And now, oh, it didn't change, huh? Now, what's 4 divided by 2? It's 2. So the square root of x to the 4th is x squared. Simple. Same thing here. The square root of a to the 4th. Well, the variable we have is a. What is 4 divided by 2? It's 2. So the square root of a to the 4th is a squared. And once again, why is that? Because a squared times a squared is a to the 4th. Because remember, when you multiply monomials, and we'll get to this later, you add exponents. 2 plus 2 is 4. All right, that's why that works. Same thing here. The square root of y to the 4th. Keep your variable. Whoops, sloppily written y. What is half of 4? What's 4 divided by 2? It's 2. So the square root of y to the 4th is y to the 2nd. Same thing here. The square root of x to the 6th. Keep the variable. What's half of 6? Or 6 divided by 2? It's 3. So the square root of x to the 6th is always x to the 3rd. What's the square root of a to the 6th? Well, a to the 3rd. Same thing. What's the square root of y to the 6th? Y to the 3rd. Simple. Last but not least down here, the square root of x to the 8th. Keep the x. What's 8 divided by 2? You get x to the 4th. So the square root of x to the 8th is x to the 4th. Simple. Square root of b to the 8th, b to the 4th. Square root of y to the 8th, y to the 4th. Guys, that's all you have to do when you see this. So if I throw something to you like the square root of x to the 10th, you will say to me, the square root is x to the 5th, because 10 divided by 2 is 5. Guys, that's all this is for simplifying perfect squares. Any questions, please email me in the description below. Comment on what you like, comment on what you didn't like. Please subscribe, like, and share. And as always, guys, stay safe. Thank you for watching, and I will absolutely see you on the next lesson.